Okay, so today we'll be talking about creating drivers in VOLTTRON. So for those of you who don't know, the VOLTTRON driver framework is a set of VOLTTRON uh, agent and driver code that provides a way for VOLTTRON agents to get data from devices. So when a device wants data, or when an agent wants data from a device, it will either send a request to a special agent called a master driver agent to request specific points off the device, or it will subscribe to publishes to the pub sub. So the way that the master driver collects information to the device is through the driver framework. So a driver is a interface and collection of registers, and those are Python classes that exist in the VOLTTRON repository. And the master driver uses those classes to collect the information via the protocol of communication for the device. So for example, the Modbus device, or a Modbus device, has a Modbus interface and a collection of registers. The master driver will receive a request from an agent to scrape a register on that device. So it will find the correct interface for the Modbus device and then use that interface to get the data from the register. So to be very specific, the master driver is a special agent that handles all of that communication. And then drivers are essentially sub-agents running under that process. So to create a new driver, you will create a Python file under the master driver's interfaces directory with the name of that driver. So for the case of the Modbus driver, you would create it in master driver interfaces Modbus. Inside of that file, you will create an interface class and one or more register classes based on the needs of the device. For any documentation you may require for this process, the driver development, there's a driver development guide at this link. You can go that here, or when the 7.0 release candidate is pushed to develop, the driver creation walkthrough will be available in agent development walkthroughs. There is some overlap in what they cover. The walkthrough will provide a step-by-step walkthrough for creating a CSV device driver, which is actually what I'll be covering today. In the meantime, I'd like to discuss interfaces, registers, and how to implement them. So when the master driver starts up, it reads a set of configuration files. And these configuration files are device configurations and registry configurations. So here we have an example of a device configuration. The device configuration is specific to each driver. But in essence, what it does is specifies which driver file to use. So that's specified by the driver type parameter. Here I've given it the CSV driver, which is the name of the example driver I've built for this demonstration. We also specify a path to a registry config file and a scrape interval, and there's a few other sort of optional items here, such as the time zone and any driver specific information you'd like to provide, which comes under this object here. So I've specified that I'd like to provide a path to my quote-unquote CSV device. So the registry configuration, as the name implies, helps the device, or I'm sorry, the driver be configured per register, so we specify the path to it. When that registry configuration is loaded into the config store, it becomes available to the device, assuming that it's been configured properly. We'll go over the configuration steps a little bit later in the tutorial. This is a registry configuration file. They differ a lot in their form, but in essence, what you are attempting to do is to specify what registers are available on the device and how they can be communicated with. So here, since we have a very simple example device, which is reading a CSV file, we can specify which lines of the CSV to read and whether or not we are allowing them to be written to. We also provide a mapping between what VOLTTRON will call them and what they are called on the device. In this particular case, I've called them the same thing, but you may, if you were, say, doing this for an actual device, you might have something like, sensor 5, and that sensor might be a heat pump sensor, so you might choose to have your VOLTTRON point name be heat pump sensor. So you'll load these two configurations into VOLTTRON after installing the master driver, and that will tell the master driver to use these configurations to set up a device driver. So what happens at that point is it looks for that file that we discussed earlier under the interfaces directory, and it creates an instance of the interface class based on the configuration values. So the interface class is the class for specifying the actual interface to the device. When you are implementing the interface class, it should inherit the base interface class, which is in the master driver's init file, and it has a few required methods to implement, and then provide some basic functionality. So it provides some basic configuration, provides a mapping of registers, bit and byte, and whether or not they're writable or not, and then provides methods for determining which registers to use based on their configuration values, and for adding and removing registers, and then abstract methods for setting points, getting points, and scraping. Revert all and revert point may not necessarily be implemented based on the requirements of your device. For the CSV device, we will not be implementing them. However, you'll see other drivers included with the platform. Specifically, I can think of the Modbus driver includes these. That, again, will just depend on the implementation details. Get multiple points will allow you to get some, but not all. Okay, so to create an interface class, you will create a new interface class inheriting the base interface inside of the driver file. Then you will you'll implement a few methods. So you'll interface or create the configure method, as well as get point, set point, and scrape all at an absolute minimum. Again, the details of the device may require you to add more or less functionality. The driver creation walkthrough documentation that we have here provides a skeleton for a very basic interface class. Okay, and then once you've created that skeleton, we'll create skeletons for one or more register classes. The register class, again, will inherit from the base register in the init.py file for the master driver and provide some default functionality and configuration values. So here's the default configuration values, the units for the device's point name, whether or not it can be read, that sort of thing, and provides getters for those various configuration values. The details of what the register class does is very heavily dependent upon the actual implementation. So for example, in the BACnet driver, the register class essentially only contains the configuration values, and those values are used to get the points. Whereas in the Modbus driver, there are multiple register classes, and each register class is actually responsible for performing the communication. In the case of the CSV driver, just as an example, we're going to have the register class perform the communication, or in the case of the CSV driver, the actual file read. So again, the driver creation walkthrough provides a little bit of a skeleton. The skeleton for register is very simple. We just inherit the base register and create a register class. The interface class must be called interface because that is how the master driver agent creates its instance. The register class can be named as necessary for the operation of your particular interface. For the purposes of the CSV driver, we're just going to have one interface, and that's going to be called, or I'm sorry, one register, which is going to be called the CSV register. And all it will do is read a line of a CSV file. So the skeleton code here does the basic configuration and references that base register. So then we can go into the actual implementation details. So the way the CSV driver is going to work is we're going to have our interface class determine which registers to read and write, and then ask those registers to handle that communication. And then we'll also do some additional configuration. So for example, from that register, from the device configuration I showed earlier, we're going to find the path to our device, and then I've created up here a set of device points which we're going to write to this CSV path if it doesn't already exist, just so we can make sure we have something for testing. We then continue to parse the registry config. So here we go to our registry config and we use that to create instances of the CSV register classes. We do a little bit of error checking and that sort of thing, but the main thing that we're doing here is creating these register classes based on the registry configuration. And you can see that they're being added to the interface via the insert register method. Finally, the register class actually does the communication. So we can, or the interface class, and the interface class manages that. So the interface class says, okay, get the register we want and get its state. Or for set point, get the register we want to set, make sure it's not configured to read only, and then set its value. And you can see that it's the register actually doing the work in each case. The scrape all method is very simple. Find all of the registers we have, and then for each one, iterate over that list and get their states, and then publish them. So we then have our register class, which again is doing our actual work. So here we have, we're configured with the CSV path passed down from the interface class. We have a getState method, which opens our CSV file based on that configured value, iterates over it to find our point, and when it finds the point, it returns it. There's some additional error handling in there as well. SetState, iterate over each point. If it's not the point we're looking for, save it for later. If it is the correct point, create a copy, update the value of that copy to the value we want to set it as, add that back in, continue iterating until we're done. When we're all done, we overwrite the CSV file, and then we publish, or we return our state showing that we've updated. All right, so basically what will happen at runtime, we install the master driver, we then configure it with the configuration files that necessary for the device and the registry configurations, and then when that starts up, it will create an instance of the interface class. The interface class will create several instances of registers based on the configured values, and then periodically the master driver will do the scrape all method, which iterates over all the registers, collects their values, and publishes them. Here, these are just documentation of the configurations that I provided. They're the exact same ones we've already went over in the video. So to test the basic functionality of our driver, we can install a master driver and a listener. These are the commands you'll want to run. I'll go over them at the end of the recording, but they're here for you right now. So we're going to basically install some agents with some configuration values and then use the config store to actually store the configurations. I've already actually done this, and we can see them here. Sorry. Okay, we can see that those agents are actually already running. I'm going to, for the time being, shut off the testing agent and the actuator so you can see just the master driver and listener agent. Whoop. Okay, so once you've started the master driver and listener, you'll see a periodic publish based on the device configuration that will look something like this. It will show all of the points, their corresponding values, and then some metadata explaining things about each of those registers. So that shows you that the get state from the register class and the scrape all methods are doing their jobs. To test the set state and set point functionality is a bit more involved. So for this purpose, I've created a test agent. So we can take a look at that. What this test agent will do is has a very simple configuration. You provided the topic of the CSV. Basically, when you've installed the configuration, you've installed it under devices / campus / building / point. That campus building point topic is what will be configured here. And then it will create this, basically handle all of the normal configuration. And then in the configuration, we have something that handles the pub sub, and we can see that we've created a subscription, calls a callback, which creates a logging entry. More importantly, in our onStart method, we create a periodic callback. So every 30 seconds, the core agent will call this callback based on this value, and the callback is this function, actuate point. What actuate point does is it sends an RPC call to the actuator agent, asking the agent to ask the driver to set the point. So the way that works is you create a starting and ending timestamp, wrap those in a list, and send that in an RPC call to the actuator. So RPC call to the actuator requesting a schedule for the agent that we're currently using. We can name it any arbitrary schedule name, give it high priority. Not really necessary in the testing case, but nonetheless that works fine, provided our schedule. And what this does is asks the driver framework to provide a gap of time that the device will not be busy. Then we find the point topic we're going to use. I'm just asking for a single topic just so we can see that this works. We then send an RPC call to the actuator to set that point, and we then alternate the value that we're setting. So every 30 seconds or so, we should see that a publish will come through where this value alternates. So we can start those two agents again. And now we should see our values alternating. Okay, so we can see our values are 1 and 1 up here. So this is the one we would expect to change. So every 30 seconds or so, based on the publishing frequency and the way times line up, we should see this alternate between 1 and 0. Okay, we can see just up here, we've requested this is requesting our scheduled time. And now we can see that the point has been set to 0. So that's a good indication that the basic functionalities of the driver are working. Okay. So back in the driver walkthrough, you can see again the commands required to set that all up, and you can see an example of what a publish should look like, which is right here. I've also provided the exact code for my test agent. Should you choose to use this, I highly recommend you take this agent and adapt it for your own purposes just for a really basic test. But beyond that, as always, I really highly recommend writing any sort of unit and integration tests that you can. Sometimes these devices can be a little tricky, but it's a really good idea. All right. So now we'll cover the commands to go through and set all of this up. So I'm going to clear out my agents. This will, okay, so the first thing that we'll have to do is activate our environment like normally, .env bin activate in the VOLTTRON root directory. We can now see that our environment is activated just like normal. We can then start the platform. /start VOLTTRON is a good way to do that. That will run VOLTTRON in the background so that we can continue to use this terminal. And now you can tail the logs down here in a separate terminal window to see what's actually going on with the platform. You can use vctl status to see which agents are installed. I'm going to remove those agents so that I can show you how configuration works. Okay, so if we run status again, we can see that there are no installed agents. So installing agents is pretty simple. We're going to invoke Python, and then the scripts /install agent.py file, which will install an agent. We provided -s and then this source directory of the agent. So for the listener, we'll provide examples /listener agent. And since we are not going to configure our listener agent, that's all we need to do. We can vctl status and see that that's been installed. The master driver, very similar, Python scripts /install agent.py -s and then services core master driver agent. And then for this one, we'll provide a configuration. I'm going to use the configuration file using -c. We can store that. And then I'm going to use examples /configuration /drivers and then master-driver.agent. It's a really basic configuration. We can actually show you that. Configurations, drivers, and then there it is. So this is the offset between scraping individual registers and then the way things are published. Really basic. Okay, hit enter. Okay. So we can see that that's been installed. Installing device drivers just basically requires us to use the VOLTTRON config store. So the way we're going to do that is we're going to use the command vctl config and then list store and delete as necessary to store configurations. So in this case, we're going to use the vctl config and then store platform.driver. The platform.driver is the name or the identity of the master driver. So what this is saying is store a configuration for the master driver, and then we're going to specify the path to the device or the device topic. So that's going to be always devices and then a campus. So we're going to say PNNL, and then building, I'm in ISB1, and then the device. So CSV underscore driver, and then we give it the path to that configuration. So I've provided that configuration in the CSV driver directory of the examples. So examples CSV driver, and then CSV driver.config. Okay, so we can do vctl config list platform.driver, and that will list all the configurations stored for that driver, or for that agent. In this case, we actually have some remnants that had previously been stored. We'll go through the second configuration, so that was for the device. Essentially the configuration for the interface class that we discussed earlier. Now we're going to repeat a very similar process where we're going to invoke config store platform.driver. Then here we're going to give it the exact path to the CSV configuration that was in the driver configuration. So that would be whatever comes after config colon and then the double slash. So CSV registers.csv. And we could actually see that that was the case up there as well. Okay, and then we give it the path to that file, the actual file. So examples, CSV driver, CSV registers, CSV. And then for any config files that are not JSON format, you should do a double dash and then that format. So double dash CSV. Looks like I made a mistake. Yeah, I spelled it, the path a little bit wrong. This guy is not capitalized. Okay. And we can list them out again. They're right up there. Okay. So we can do vctl status. We've got those two ready to go. And there they go, running. Perfect. So we'll stop them for now. So what it's complaining about here is likely due to some changes just in the hierarchy. But you could see earlier how things were working. So very similar process with the actuator. We'll go our install, and we'll give it the path to services core actuator agent. And then also path to our example agent, which is the CSV driver agent. So examples, CSV driver agent, and we can give it this config. Okay. Now we can do one more VCTL status, and we can see them all installed. And then you can follow the guide from earlier to see all that working. That concludes the tutorial. Again, you can find the driver agent documentation or driver development documentation at this link. And hopefully the driver creation walkthrough will be uploaded into the walkthroughs very soon. But if not, my email is james.larson@pnnl, and you can send an email to me and I will provide you this documentation. Thank you.